In this video tutorial, we're going to analyze a pick and place sequence. We're going to write the sequence in Siemens logo ladder logic, and we're going to simulate. The machine has three actuators: a vertical, a horizontal, and the grippers. And there are proc switches on the vertical and horizontal actuators, but none on the grippers. The sequence analysis: we wait for part, we move down to get the part. When we reach the down switch, we close the grippers. We wait for a time, we move up, move right, move down, open the grippers, move up, and move left back to the start position again. Analyzing the sequence like this is always a good idea before starting to write code. First step is File, New Ladder Program. We set up the project properties. We're going to name the I/O points just for convenience. We'll put in some document information. I like to set the grid spacing to 75 pixels and turn off the grid itself. One little interface quirk that's worth pointing out is that if you click and hold down the mouse button and drag a component from the instruction set onto the page, when you release the mouse button, it gets placed somewhere else. The secret to this is to let go the button after you've selected the tool and then click, and they get placed exactly where you want them. We identified 9 steps in our sequence, 10 to 18 we've numbered them, and we're going to use marker flags 10 to 18 to keep track of where we are in the sequence. The Logosoft doesn't allow us to use a contact of a coil unless the coil actually exists, so we create those first. Dropping a coil on defaults to a Q, and we need to manually change those to the marker flag that we want for each point. Again, document as you go. We'll give the names to each marker flags as defined in our sequence on the right. Now we can rearrange the coils onto their separate rungs. So the sequence here is a bit like passing the baton in a relay race. There can only be one baton in the race, and we're going to make sure that the sequence can't restart unless all the subsequent stages are off. So M10 is the initial wait, and for that to turn on, all the other steps, M11 to M18, must be off. M11 is the move down step, so we say that M10 must be on. It's waiting for input 2, the down switch, so we add that in. We're going to latch the M11 coil until M12 turns on, at which stage we unlatch it. So in that way we're going to pass the baton from M11 to M12. This is a standard latch circuit from basic electrical circuit theory. M12 is the closed gripper stage. It turns on when M11 is on and the down switch is reached, and turns off when the grippers are closed. Now, we said there was no proc switch on the gripper, so we're going to add in a timer just to allow enough time for the grippers to close before the sequence moves on, and I've set this time delay to 3 seconds just so we can see it in the simulation. The program PDF and program file are both available for download on the quickplc.com website, so I won't bore you with the drawing of each step here. Just look at the top left corner to see what's going on. Now we've reached the bottom of the first page, so hit the Pages button on the toolbar and we'll set to 3 pages, which should be plenty for this application. M16, again we need a timer for the grippers open, and we use the timer contact in M17, and M18 gets special treatment. Since there's no following sequence step, we just wait until the left switch turns on. That unlatches M18 and allows M10 to turn on, which will allow another sequence to start. Regular viewers of the channel will know that I like the message text box for showing on the logo LCD where in the sequence we are. We can use it for alarm messages, but in this case we'll use it just to show where in the sequence we are. So we'll create all of those, and note we can add in the time value on the grippers closed, so we can see how the timer is running. Select the timer from the block list on the left, remaining time, insert at the cursor position, and OK that. One thing I like to do on the logo and in the simulation is turn on the backlight. So we drop an output coil there and we notice that M25 is reserved for the logo display backlight, and we just wire that so it's permanently on. We're ready to test the sequence. So we're going to, first of all, to make the sequence a bit easier to simulate, we're just going to set all the inputs as momentary so that we don't have to turn them on and off. We just have to click them once. For the sequence, we turn on simulation mode, and we can see that M10 is energized and the logo display is showing us as waiting for part present. We scroll down and we can see this rung is ready to go except for the part present. Turning that on turns on M11, and we notice that the display updates. M11 is waiting for the down switch. We turn that on, and that turns on M12 and turns on the timer. Now since we're only waiting for a time there, that after the 3 seconds has turned on M13, telling us to go up. Now we're waiting for the up limit switch again. I click that. M14 turns on. We give the right switch. That gives M15 instruction to move down. We turn on the down switch. That starts the open grippers time delay. And after 3 seconds, that will have turned on M17, which is the move up command. We're now waiting for the up limit switch. Turn that on, and we're now waiting for the machine to get back home. So when we turn on the left limit switch, that's going to unlatch M18. And if we go back to the top of the program, we find that M10 is on again, ready to start the next sequence when a part becomes present. Running the sequence again, just watch the status lights at the bottom. So we've gone from M10 to M11. We turn on input 2, we go to M12, 13, 14, 15, 16, 17, And once we get the left switch input 4, the circuit resets back to M10 again. We now want to add the output logic to the program. So we can see from the list that we want the Q1 to turn on at step 11, 12, 15 and 16. So we'll just OR those contacts. That's one done. We can see that Q2 needs to turn on for steps 14, 15, 16 and 17. Or those contacts as before. And finally we need the grippers to close on steps 12, 13, 14 and 15. Again, you can see the wisdom of defining your sequence at the start. It just makes programming so much easier. And that's it. There are 3 outputs done, and easy to modify should the need arise. So running the sequence again, simulation mode, move the message display panel up. We're at step 10, so all outputs should be off. Move to step 11 and we have Q1 is on. Move to step 12 and we have Q1 and Q3 on. Step 13, we move back up. Step 14, move right, we have Q2 and Q3 on. Step 15, all 3 solenoids are on. Step 16, we open the grippers. We have a time delay and it immediately moves on to the move up step. So we've only got the Q2 on, holding it in the rightmost position until we reach the up switch, at which stage we turn off all the solenoids to return it to the left home position. As soon as we make the home switch, we revert back to step 10, ready for the next sequence. So that's it. I hope you enjoyed the tutorial and get something out of it. Stay tuned for more. Thanks.